Or is it just 20,000?
Yep.
The active years.
Any idea how you do B?
I just substituted T for 4.
Okay, what did you get?
£14,330 63.
Yes, fine. And then sketch the graph. I think you'd be okay for, am I right?
Yeah, I reckon.
What would be the y-intercept?
Um, where V equals 0. So is it just 20,000?
That would be where t equals 0, am I right?
Yeah, true.
Yeah. And so what shape will the graph be?
Like like that.
Yeah, yeah.
So
Exponential graph.
yeah.
Okay, Grant. Okay, any questions there?
No.
Okay, I just want to, just for the sake of doing it. Sorry. Capture. Oh, it did work. It's just tiny. Okay, fine. I'll just make sure. £20,000, 14,000 odd, and the graph. Hold on, that's not the graph I did. Why is this graph going the other way?
Because value descend, that decreases.
That's the x. It's the power of a negative. And also, silly me, why does it not go to the left side?
I don't know. Because T for 0.
Yeah, because you can't have -1 seconds. So the graph goes like that and then down. Okay. I just want to see if this is worth doing. No. No. Sketch the graph. How about part D?
Use this model. No,
Why not?
because it doesn't take into account of like famine, like because it's assuming that it's just gonna increase like or decrease constant.
Yeah. Actually, I suppose we could check. How could you check what its prediction would be?
Just put 500 in
500.
FT.
Yeah. So I just wonder what that is. 20 plus 10 shift E to the 10, 500 over 50. And so it's saying the population of the country will be 220,000. What's the starting population of the country? Oh, sorry, T is in thousands. Sorry, population is in thousands. And so this would be the population times by 1,000. And so the population of the country would be 1, 2, 3, 4, 5, 6. So 220, I don't know what that is, billion? So it seems like, yeah. 2000. The model predicts the population to be over 220 million. This is highly unlikely, and by 2500, new factors are likely to affect population. Okay, so I think for this type of question, it doesn't hurt to actually find out what the value would be. Yeah, in maths, never hurts to give a number in your answer. What is meant by part B, or how would you do that?
What is the long-term prediction of how this disease will spread? Does it want you to give like your own T and see if it's decreasing or increasing?
Okay, so what T could you try?
Long term, I don't know, 50.
Okay, okay, try it.
Are you doing 50 or 50 is 300?
It's 300. I'm gonna do 99999. I also get 300. And so what does that tell you?
It doesn't spread. And there's a number of people, so the number of people infected stays the same.
At what?
T is the time in years after detection. So the number of people infected stays the same after it was first detected.
And is there any other number you could put in for T to test this?
Zero?
Yes. 0, 1, something like that. So we did one extreme, and now we could do the other extreme.
0 is 200.
Okay, and I put in 1 and I got 239. And so basically it starts at 300 minus 100, which is 200. So starts by so part A I think was 200. 200 infected. And long term, what happens long term?
It stops at 300.
Yeah, stops at 300 people infected. Any questions there?
No.
Okay, I just want to see how they phrase the answer. The long-term prediction suggests T approaches infinity. As T approaches infinity, E approaches 0. And so, okay, that's all we had to say. So 300 is enough for the marks. How would you do D for this question?
Suggest one reason why this model will stop giving valid results. Is this the same thing like it? It's infinite.
Yes, appears to be. The model will stop giving a valid result for large enough values of T as new factors are likely to affect population growth, such as rabbits running out of food or space. Okay, I've got it. So this is an exam question. Let's try it.
All of it.
Yeah, might as well. No, hold on. Let's try this one. Yeah. It's also an exam question.
All of that one.
Yeah, it appears to be a more difficult exam question.
I just bought a tractor for 20k. He wants to model the depreciation of the value of his tractor, T pounds in 2 years. His friend says 2 models. Newspaper will predict the value of the tractor after 1 year. So you just substitute 1 into it.
Into both of them? That's fine. I think you'll be okay for that one.
Yeah.
How about B?
Use both models to predict the value of the tractor for 10 years. That's just to substitute it for 10.
Yeah. How do you sketch a graph?
Sketch a graph of t against t for both models. So t along time along the bottom. Price along the top, and then intersects at 20k and 19k, and then you just
how if someone didn't know what the y-intercept was, or the capital T intercept, I suppose you could call it, what would you have to sub in to get that intercept?
time needs to equal 0.
And so if you subbed small t equals 0 into model 2, what would you get?
Model 2.
Yeah.
$19k. Oh wait, now 20k.
That's
No
it.
idea.
That's it. So yeah, basically when you sub it in, you get 19,000 times 1 plus 1,000. So just be careful with that. So actually both of them have a y-intercept of 20,000. And part D, how would you do that?
Interpret the meaning of the 1,000 in Model 2 and suggest why this might make Model 2 more realistic. He wants to know the depreciation value. Does the longer you have the tractor, what was the longer you have the tractor, increase in value? Why would it increase in value?
You tell me. There's a clue in the question.
Depreciation.
Yeah. What does that mean?
Oh, it is going down.
Goes down in value because it's to a negative index.
Yeah. Yeah.
Right.
That.
And so why is the plus 1,000 possibly more realistic, or what is the significance of it? What is so the longer he owns the tractor, how could you get a number that would represent that?
Sub T in for a random number.
Pick one. What random number would you pick?
20.
Yeah, so some large number. And if you sub the large number for T into model 2, what would you get?
£1,115, 84.
Any idea what would happen if you put an even larger value in, like 999, something like that?
$1,000. But that was only, yeah.
Go on.
It would, if we didn't add the 1,000 on the end, it would have been 0. But because you added the 1,000 on.
That's it. So the longer Nigel owns the tractor, the lower the value it would have, steadying out at £1,000.
Yeah.
And why is that more realistic?
Because it just wouldn't be for free.
Yes, because a tractor would not be free. It would always have some value.
Yeah.
Some value. Okay, any questions there? Okay, I just want to see how they phrased it. This doesn't crash. In Model 2, the tractor will always be worth at least £1,000. This could be the value of the tractor as scrap metal. I was thinking the same thing. Okay, that's that. Exponential modelling, X a half or tick, you've got it.
I reckon tip.
Yeah, I agree. I didn't have my pen at the time. Hang on. There you go. You don't need to be 100%. So that's exponential modelling. That's just, I just wanted to make sure that you were okay for those like worded questions. So I want to do A2. Is there any topic in particular you want to start with? If you like, we can just do it from the ground up, or have you already started it in school?
I think we've done a bit on sequences and series, and that's about it.
Okay. If you like, we can start from chapter 1.
Yeah.
Okay. So this is proof by contradiction. How are you at this proof stuff?
I'm not very good, if I'm honest.
So nobody is, and it's new for A level, and so it's not been taught very well either. Like teachers don't have much experience at doing it.
Yeah.
And so I just want to take a look at this. So these are some other proof ones from AS. I think we'll just look at these first. And some of the proof stuff at AS is like it's easy peasy. It's not really proof, but then some of it is. Okay, any idea how you'd do this?
Prove that when n is an integer and n is bigger than or equal to 1 and less than, that m equals n plus 2 is not divisible by 10. So you just do all the different possibilities of n, and
What are those possibilities?
1, 2, 3, 4, 5, 6.
Yes. And do you know what that's called? What method of proof that is?
No.
That's called proof by exhaustion. It just means exhausting all possibilities. And so if they say prove by exhaustion, that means try all possibilities.
Yeah.
And I'm sure you'd be okay for that. Example, when n equals 1, m equals 3, and 3 is not divisible by 10, so the statement is not true. Do that for each one of them. Okay, how about this?
Prove that every odd integer between 2 and 26 is either prime or product of the two primes. Is that proof by exhaustion as well?
Yep. So pick an example. We'll do one.
So 3 is either a prime product of the two primes. 3 is a prime number.
Can you pick one that is not a prime number?
15.
Okay, so 15.
Is that a product of two primes? 5 and 3, yeah.
Yeah, 15 is a product of two primes, 5 and 3, I believe you said. Okay, and you would just repeat those for everything. Okay, just want to see how they did it. So 3, 5, 7, etc. are the prime numbers between 2 and 26. The other odd numbers between 2 and 26 are 9, 15, 21, 25. 9, 15. So every odd integer. Okay, and actually there's this little last sentence is necessary. You just copy and paste from the question. So you can see here, prove that. And then you have this bit here. Every odd integer between 2 and 26 is either prime or the product of two primes. And the very last thing you write should be a copy paste of that. Therefore, or so, every odd integer between 2 and 26 is either prime or the product of two primes. this last statement here is worth 1 mark. And you just copy and paste it from the question. Any question that says show that or prove that, that's how you get the final mark. So the other stuff up here might be worth 2 or 3 marks, but you would lose 1 mark if you didn't say this thing at the end. Seems obvious, but yeah. Okay, how would you do this one?
Prove that the sum of 2 consecutive square numbers between 1 square that is an odd number. The sum of 2 consecutive is an odd number. So is that exhaustion as well?
Yeah, and
so 1 squared plus 2 squared is 4 plus 1 is 5.
It's 5, and equals 5.
3 squared plus 4 squared is 12 plus 9. No. 3 squared 16 plus 9, which is 25, which is my number as well.
I'm not sure if you did intentionally, but you skipped one.
Oh, yeah, I did, but are we doing all of them?
No. What one did you skip?
2 squared plus 3 squared.
Yeah, and did you skip that intentionally?
Yeah, I thought we were just doing random ones.
No, that's fine. I'm just making sure. Okay. Got it. So odd. Oh, okay, so they didn't even say it. They just said equals odd. So the sum. Oh yeah, and then they did the last final mark. So the sum of 2 consecutive, etc. Okay. Exam question. Let's take a look at this.
Prove that all cube numbers are either a multiple of 9 or 1 more or 1 less than a multiple of 9. Okay, so cube numbers are like 1 cubed.
This says all cube numbers. How could you do that?
You can just disprove it. Wait, so isn't 1 cubed 1?
Are multiples are a multiple of 9 or 1 more or 1 less than a multiple of 9? Okay. How do you go about proving this? Because this is all cube numbers.
Is it algebra?
Yeah.
Okay, so x cubed equals 9x.
And I'm just going to call it n.
Okay.
So x is an unknown number, n is a known counting number. So n cubed equals 9n?
Yeah. Or 9n minus 1. Or n cubed equals 9n plus 1.
Okay, any idea how you do this?
No.
Prove that all cube numbers are either a multiple of 9 or 1 more or 1 less than a multiple of 9. Am I crazy, or do they mean except for 1 itself? Is 1 not a cube?
That's what I was thinking, because 1 cubed is just 1.
Yeah, so I think except for 1. So 2 cubed is 8, which is 1 less. 3 cubed is 27, which is a multiple. 4 cubed is 64, which is 1 more. How do we prove it for all of them? My guess is we factorize them. So how would you go about factorizing the first one?
Take n out.
How?
Wait, should we do it equal to 0 first?
Yeah.
So n cubed minus 9n equals 0.
Yeah.
And then take a factor of n out, so you get n squared minus 9 equals 0. So n either equals 0 or n equals... Wait, do I need to do that? Do I need to find out what n is?
You can factorize the single bracket into two brackets.
So n plus 3 and n minus.
Yeah. And so what we said when n is 1, that doesn't count. So okay, so what would this get us if you were to solve this then?
What do you mean?
Let's think about this. So for all values of n, so if we were to solve this, n equals 0, n equals minus 3, or n equals positive 3.
Yeah.
Maybe that's one step too far. For every value of n, if we were to sub in, I don't know. Let me see. Break down the integers into numbers divisible by 3 and numbers giving a remainder. So they started by calling it 3n cubed.
Why?
Let's see. And numbers giving... Let's see. Break down the integers into numbers divisible by 3 and numbers giving a remainder of 1 or 2 when divided by 3. So 3n cubed equals 27n cubed. Oh, that's a multiple of 9. They said 3n plus 1 cubed and 3n plus 2 cubed. So they did what we did, except
Will you put the 3?
they have it as 3n. Just want to check. Prove that all cube numbers are either a multiple.
Because then, if you did the 3n, then you can, then how they've got the 9n outside the bracket, then you can just say so they're all multiples of 9.
So that's going to be a multiple of 9.
Yeah, because it's times by 9.
Then the other two, the plus 1 and plus 2, so they used plus 2 instead of minus 1, but the same, you get the same, it'd be the same idea. For both of them, they factorized out 9n, and then this one is plus 1, so it's one bigger than a multiple of 9, and then this one is plus 8, which is one less than a multiple of 9. Another way would be to say it's minus 1. If you were to put in minus 1, it would be one less than a multiple of 9. 9n is a multiple of 9. Just how did they know to use 3n? So all cube numbers are either a multiple of 9. That was very tricky. If you were to put in 2n, 8. Now, I think they knew that the smallest number, that you would need a coefficient of some kind, and that the coefficient 1 is too small, 2 is too small, and so the smallest one that will work is 3. I think every other coefficient works, 4, 5, 6, 7. Let's see. So what if it was a square number? Any idea what you'd do there? If you were to look at what the multiples of square numbers are.
Do we need to put a coefficient for the n squared?
Yeah.
So 3n squared.
So I think maybe even 2n squared would work, but let's try 3n squared. What is that?
What do you mean, what is that?
What is 3n squared?
I don't know.
3n times 3n?
9n squared.
Yeah. Let's try 3n plus 1 squared.
9n squared plus 6n plus 1.
And let's try 3n plus 2.
9n squared plus 12n plus 4.
Plus 4. And so is there anything we can show here?
You can factor out the 3 and... Oh, hang on. I don't know.
So this one up here, you could factorize out 9n, I suppose.
Yes, then you just get 9 and n. Yeah.
So a square number of that format will always be a multiple of 9. How about this one?
You can do 3. You can factor out 3n.
So if you factorized out 3n, what would you get?
3n, then bracket 3n plus 2. Oh wait.
And then what I would do is just separately plus 1. And
Yeah.
so what do you know about 3n plus 1 squared?
That whatever, that's going to be a multiple of 3, add 1.
Yeah, so that will always be 1 more than a multiple of 3.
Yeah.
And
Yeah.
then how about this one down here?
Factor out 3n again. So 3n plus 4 bracket plus 4.
And so what do you know about this one?
Isn't it? Is that 1 less than a multiple of 3?
1 less than a multiple of 3. I'm going to say it's 4 more than a multiple of 3.
Yeah, I thought that. I just don't know why I said 1 less. So what would 1 less look like?
Well, 1 less would be minus 1. My guess is it would also be plus 2, because that's 1 less than 3.
If the end part was plus 2.
If the end part was plus 2, you can make this one simpler. If it's if this one is plus 4, so 4 bigger than a multiple of 3, can you make that simpler?
Four bigger than a multiple of 3.
Yeah.
Make that simpler. No, I don't know.
It's always
Yeah.
it's always 1 bigger than a multiple of 3. Why is that?
Because 4 is 1 bigger than 3.
Yes. So basically, if it's going up in 3 is a multiple of 3, so it's 1 bigger. So this one is this one down the bottom is 1 bigger than a multiple of 3. This one up here is also 1 bigger than a multiple of 3.
Okay.
Any questions there?
No.
All right. Yeah, this proving stuff. That was the tricky exam question anyway. Yes. So find a counterexample.
Find a counterexample to disprove each of the following statements. If n is a positive integer, then n4 minus net n is divisible by 4. If n is a positive integer, then n is divisible by 4. So then just put in a number. That disproves it. You found one yet? Oh, wait, how did you do that?
So
Do you put it in the table?
yeah. So mode table. And so any idea how you input this to check it?
No.
I'll show you.
How'd you get?
So did you get this far? Did you
How do you type in FX?
did you press mode?
Where's mode?
Next to on, top right. This button.
I haven't got mode. I've got menu.
Press menu. What does it say?
That's menu.
Can you find table?
Yeah.
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 Okay. And so what does it say for your table?
Like that.
Oh, there you go. So you've got x to the 4 minus x.
Yeah.
I believe you press equals.
It only goes up to 6 though. How do I make it go up to like more?
So what I have start at 1 because it says positive integer.
Yeah.
And end at does yours end at 6? Are you able to press like input 10?
Yeah.
So I'm going to say end at 10. Usually it chooses 10 is enough, and going up in steps of
Okay. 14's not divisible by 4, is it?
Oh, did I go wrong somewhere? I must have. Let me see. AC X. Oh, I did. Yeah, 14. So I think like immediately it's
2. N equals 2.
So there we go. And so yes, if so, n equals 2. N to the 4 minus n equals 14, and not divisible by 4. Okay, how about B?
Integers always have an even number of factors. One's only got 1.
Yes, 1 has 1 factor and 1 is odd. How would you do C?
2x squared minus 6x. Is positive. What's the question? Is positive for
all values.
16 minus 10 to 10. No, not for 1 or 2.
Yes. Okay. So when n equals 1, 2n squared minus 6n plus 1 equals minus 3. Minus 3 is negative. Okay.
Yeah.
And this one is a multiple of 3 for all integer values of n. I think you're okay for that because you're good with the table.
Yeah.
Any questions there?
No.
Okay, I just want to see what format answer they're looking for. Let's see, so 2, so they just subbed in 1, which is negative. Any square number has an odd number of factors. For example, 25 has 3 factors. That's what we were looking at. That's what we were doing. Okay, exam question. Let's take a look at this. Okay, identify the error.
Student trying to prove that x cubed plus y cubed is less than x cubed plus y cubed is x cubed plus 3x squared y plus 3x y squared plus y cubed is less than since which is less than x cubed plus y cubed since 3x squared y plus 3x y squared is bigger than 0. Identify the error made. It's not 3x squared y, is it?
What do you mean?
When you expand it. Oh, wait, hang on. X cubed plus 2x. Hang on. Plus 2x squared y plus y squared x plus x squared y plus 2y squared x plus y cubed 2x squared y is this. So we get 3x squared y squared. Then we get 3x, so we get x cubed plus 3 x squared y plus 3y squared x plus y cubed. So they expanded it, right?
Yeah, I believe the expansion is correct, and I used binomial expansion.
Did you? Wow.
Because I'm fancy. So x cubed plus 3 x squared y plus 3 xy squared plus y cubed.
Yeah.
I think what might help you is if you do it alphabetically. So I noticed you said like y squared x. If you write it as xy squared, then you'll see like... Sorry?
But doesn't 3xy squared look like the x and the y squared?
That would be if it was in a bracket.
Okay. Yeah, that's the only reason I did it.
So
Yeah.
it's because of Bidmuth, the index is connected only to the letter it's right next to, because you power before you multiply. XY means x times y. So I get it, like kind of looks that way. Like if that works for you, it works for you, but it does make it more difficult to actually add them up at the end. If they're not alphabetical. Okay, so the expansion is correct.
Which is less than... It's not... Why is it less than x cubed plus y cubed? It's less than x cubed plus y since 3x squared y plus 3xy squared is bigger than 0. Why is it greater than 0?
Well, why is it less than it? So they're saying that 3x squared y plus 3x squared y
3x squared y plus 3xy squared is greater than 0.
yeah, so they're saying that's greater than 0. How would you do part B?
Substitute both of them for 0. And then you get 0.
Yeah, that's true. That would make it equal to 0, wouldn't it?
Yep.
So B, x equals 0, y equals 0, or let x equal 0, let y equal 0, 3x squared y plus 3xy squared is equal to 0, not greater than 0, something like that. And so that is the error they made in their proof. 3x squared y plus 3xy squared is not less than 0.
Greater than.
Excuse me, is not greater than 0. And so part B actually helps you do part A in this one.
Yeah.
Okay. Any questions about that?
No.
We can only write this statement is greater than 0. No work has been done to prove or disprove this example when x is 0, y is 0. Yeah. How do we do this?
Prove that for all real values of x is greater than 2x plus 11. What did real mean again? Just integers?
No, any number.
Any number.
Yeah.
Prove that for all real values of x is greater than or less than. Do we just work out the inequality?
I think that would work, yeah, if you solved the inequality.
Got x equals minus 5.
Just one root, one repeat root, was it?
Yeah.
Okay, so x equals minus 5.
So what does that show?
You tell me.
It's a repeated root. I don't know.
So x squared, this is plus 12, 10.
Oh, do you substitute the minus 5 back in?
So you could, what do you get when you sub it back in?
On the left hand side you get 1, on the other side you get 1. They're equal.
What? Yeah. Is there anything you notice about this expression, x squared plus 10x plus 25? And the hint is that there's one repeated root? Or how did you solve it? Calculator?
Yeah, but it's just the two bracket thing.
What would it be in two brackets?
X plus 5,
Yeah,
x plus 5.
yeah, and that makes sense because it's, just one repeated root, minus 5. How else can you write these two brackets?
Minus 5 and minus 5. No, because that make you like a 5.
Something times itself?
X plus 5 squared.
Yeah. So x plus 5 squared is greater than or equal to 0. What do you know about square numbers?
I don't know. What do I know?
Or let's say, what's the smallest value you can get from x plus 5 squared? What's the minimum?
25.
How would you get 25? What would x have to be?
0.
Can you get a number smaller than 25?
I can do a negative.
Okay, so like what?
Minus. If we did. We did minus 10
And what do you get?
plus 5 squared. 25.
So you got the same thing. You didn't get minus 25. It kind of bounced back. Why is that?
It will always be positive.
Correct. Technically, there's one exception. Technically, it's not a positive number.
Okay.
And it's not negative either.
What?
The most special number.
I don't know. Pi. What else is there?
So you put in a number, you got 25. You put in minus 10, you got 25. Can you put in a number to get a smaller outcome?
No. I'm not getting anything. No, I can't think of anything. What else is there? Square roots.
No.
That's not.
So you tried putting in minus 10.
Yeah.
Try subbing in minus 9.
Oh, I got 16.
Can you get a smaller number?
Yeah, mine's 4. If you combat it with another square number.
So minus 4 plus 5 makes 1. So you got 1, did you? Because 1 squared is 1. Can you get a number smaller than 1?
No.
Try subbing in minus 5.
Oh. Got 0.
Yeah, so technically 0 is neither positive nor negative. So the smallest square number is 0. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 5 squared is 25. 10 squared 100. If you put in minus 1 squared, because minus times minus is a plus, it bounces back to positive.
Yeah.
Minus 3 times minus 3 is plus 9. So square numbers are always... so how could we finish this proof? We had to prove that for all real values of x, this is true. We rewrote this inequality, as x plus 5 squared is greater than or equal to 0. We said x plus 5 squared is a square number, because it's squared, for all values of x. Square numbers are always
Larger.
larger than.
the non-squared numbers.
Now, what did we just show with our calculations?
I don't know.
What was the smallest square number we could make?
0.
Yeah. So square numbers are always what?
Larger than 0.
They're always greater than, and technically we got 0.
I don't know. What?
Greater than or equal to 0?
Oh, yeah.
Or equal to 0. Therefore,
Larger and greater than or equal to 0.
Therefore, x plus 5 squared is greater than or equal to 0. And therefore, x plus 6 squared is greater than or equal to 2x plus 1 for all real values of x. So I just copied and pasted the question.
Yeah.
Values of x. So the summary for this one would be rewrite it as a square bracket is greater than or equal to 0. A square bracket must be a square number for all values of x. Square numbers are always greater than or equal to 0. Therefore, x plus 5 squared must be greater than or equal to 0. That must be true. And so the original question must be true for all real values of x. Let's see how they said it in a much simpler way. Oh, good. Their way is not simpler. So they rewrote it as a square bracket. X plus 5 squared for all real values of x. As this is equal to this, and x is equal to this, and da 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 da. So, yeah. So I just wrote it a different way. They just showed that those two were the same. We did it in the reverse order. And these ones, if you ever have to do this type of thing, it usually helps. Like you'll see in the previous one, I said factorize it. Remember that one? We kind of weren't sure what to do, but we just factorize it. Yeah, this one. That's how we do these in general. Let's see. So proving. So all the proof by exhaustion, that type of thing, proof by contradiction, you're pretty good. You just find an example. Proof by those ones, it helps to use the table. And then these other ones, for whatever reason, it often involves factorizing. How did you find that, Saba?
That's alright. Apart from like, in real life, I probably would never have known to do 3n.
So I didn't know to do it either. I just do now. Like my guess is for square numbers, this lowest number you need is 2n. For cube numbers 3n, and for like power 4 numbers 4n.
Okay.
But I'm glad. So there's nothing easy about these. There's no formula. You just have to grind them out. So next time, do you want to do chapter 1 for A2?
Yeah.
Okay. And that starts with proof by contradiction. We've actually done that, and so we'll go from there.
Okay.
Any questions for me in general?
No.
Okay. Well done, Saba. Hard work but good work. And look forward to talking again next week.
Thank you.
All right. Have a good week. Goodbye.